Key point was we realized that making some nodes to the Y have a good effect in respect to local non-uniform condition. In short, to get higher anamorphic effect, you need non-equilibrium. In starting condition, you get nothing. At the beginning, you get and after go to zero. So, according to our experience, the function of letter or everything is controlled from dynamic effect from outside. You have to simulate continuously. Otherwise, the system goes to zero. It will die. So all our efforts from 28 years were to find a procedure to produce some stimulation, but such a stimulation has to be the input power as low as possible. Just take our guideline. Make stimulation at the low power input power. About this point, we realize the role of nodes, because locally it is very high temperature, and moreover we realize the number of nodes has to be large as possible. So we developed a practical version of the Capuchin node used from the mode, Catholic mode. And the number of stars qualify the type of Capuchin. We realize as the number of stars is larger, it's better about anomalogy, but it's easy to break. So practical means the Y break. At this point, we try to find a new kind of geometry that can have all the advantage of the cappuccino without limitation of a maximum number of turns. And we have developed this one. So this is a 2 meter long original wire. Inside this coil, like a coil, but not the real coil, there is a thermocouple and another wire, field wire, that had an important value about the stimulation of an outfit. Moreover, there is at the end of my presentation one theory paper, one of our collaborators. He likes theory. Motivation, we use Constantine, alloy copper, nickel, manganese, copper 55, very old material, made about 1890, no patent, active, so no problems. The point of Constantine is able to give a very, very large amount of energy for the dissociation of hydrogen or the helium from the molecular atomic state. It can give about 1.5 up to 3, 6.6 electron volts, depending on the composition. For comparison, palladium can give 0.42 electron volts. Moreover, as other points of non-equilibrium or stress or everything, the atomic hydrogen, when recombined at a very low pressure, has a limit temperature of 56,000 degrees. It's very large. This is a measured value, not calculated, measured. Other points is the amount of loading. It means the amount of hydrogen is stored in the sub-micrometric or even nanometric surface of the constant depends inversely on the diameter and the efficiency of all the system. So the Y has to be as thin as possible, but when they are very thin, they have very large amount of heat, but very easy to break the Y. So we just to find a compromise between performance, like Formula 1 engine, and reliability of the system. This is calculation, but from real data about the ratio between the bulk of the constant and the surface active. So as you go down, this ratio increases. So 50 micron, the ratio will be 20-24. But I think very easy to break. And when you know that the multi-fractional group started developed a portion for 25 microns wide, so this is my compliment to them. Very good. But easy to break, I worry. But the point is, in our standard procedure, we give extremely large current to the Y to make it going to 900 degrees, 1000, and 20, 100 times. The current density is the order 10, 20 kilo per centimeter, time about 50, 60 milliseconds. For the experiment that I show this specific section, we used the previous iron oxidation without pulsing because we want to check how is possible even with a simple process to get some interesting result. Anyway, we can go to the older method more sophisticated. Other points, we realized that during the 7 years of experimentation, adding some iron to the surface of constant helps a lot to get the feed, and moreover, strontium oxide. Why strontium oxide is so important? Because strontium oxide, as teacher as Iwamura raised before 96, is a material that has low working function metals, low working function. So they are easy to give off electrons at high temperature. Okay, other point, potassium is used to as starter of the reaction with iron, and the manganese is used to reduce the rate of evaporation of potassium. So it's like a stabilizer of potassium with iron reaction. This discovery about the role of manganese was made about 7 years before from a Japan scientist for synthetic gasoline. So, other points is we need to have glassy sheet. The glassy sheet, special type, has the peculiarity to absorb hydrogen atoms at its surface. So the atomic hydrogen is produced from the constant and immediately absorbed on the fiber of a glassy sheet. The fiber has a diameter of about 5 microns. There are several thousand, so the surface is extremely large. This kind. So we have hydrogen, atomic hydrogen glycation, absorption both in the nanomateria of the constanta and in the fiber altogether. So this allowable immediately. Problem of this fiber take quite a long time to solve because the glass sheet is destroyed almost about 700 degrees, but we realize going to high temperature is better. So at the first we make a double sheet with the internal glass sheet, the second quartz alumina, but it was too much thick. So we were able to build a new kind of sheet, more or less patented, something like that, from the CG company. So they are crossed fiber of glass and alumina parts. So they can work up to 1,200 degrees in principle, but the constant time they give back in 1,200, so they match both needs. The people that help us for this heavy point was the nuclear company, Italy, that help us from 8 years. They have their own laboratory, they cross-check our data, so we collaborate in wonderful way. The loading is made using pure hydrogen, mainly deuterium, 1 to bar pressure. And we have found, moreover, that in experiment we have two constant wires, one connected, another free, floating, that even the second wire has some voltage at its end, so it seems impossible. It was checked from okay, good, thank you. They checked from themselves. And later we realized that it was one key point, because the material were like electron emission. So one chance of observation was the starting point for big developing. So what we have as a side effect is thermodynamic emission. So there were no reaches or no, maybe everybody of you know this formula. The key parameter is low working function materials. It's a plot about the current. It's a boiling off at the phase of wires, changing the working function of the material. Strontium oxide thick is about 2 electron volts, but a thin, very thin surface coming down to 1 electron volts. So it means if we decide to work at about 1000 Kelvin, we have 10 to 3 ampere of electrons per square centimeter. So really high value. Obviously, it's just the point of the current boiling off at the surface. The people usually think it is a true current. It's not true. It is current that is around the hot material. After we have to transport. But if you don't have electrons, you cannot transport. So this is the starting point. Okay, about the low working material, we are showing a before I quoted. So thanks again. The suggestion. Other points is we realize the nodes are points where the temperature is very, very high. So we try to increase the number of nodes. So we went to Capuchin geometry. This one. So you can see easily the temperature, very large temperature gradients inside up to 800 in this kind of experiment, outside less than 600 because color. This is the current part, quite complicated, but it's true. And the point is, we found this extra current without explanation, and we found another. We reconfirmed that the non-field effect is large when the wires are thin. So there are three possible explanations. One very trivial. The geometry, we have a lot of active material at the surface, so it works because the sponge is maximized. Another is the Nebula effect. It means like attractive force in long thin wire. Its phenomenon was discovered in 1908, after forgot, and in 95, Viennas found again, and he went very famous worldwide. Wrote a fiber method, he get star position at the European Parliament, but he found by himself. And a little bit similar, but with some variation, from Preparare and Emilio Giudice. According to them, the effect is magnified if the electrodistributor neurons are coherent along the wire. So, long and thin wire, large voltage, high temperature. This is, in short, the receipt. Other points, again, we have the field wire put at the core of the reactor, and we measure the current coming out, changing the voltage or the temperature. And we found the Bethe exponent was about 1.1, 1.3. So the theoretical child language is 1.5. So the dependence is not linear to the voltage, but larger. So means there is at least a component that remember child language equation. So true electron emission plus another parameter that we cannot discover, but was there. Why not 1.5? Why less? Why two parameters? It's what the argument of today. So we speculated that at the beginning there was like a thermodynamic converter, and the effect is enhanced because cold fusion effect. So increase temperature, you like positive feedback. Sometimes this happens, but the wire break. So this point we want to do another project, overcome the weakness of Capuchin walls that is too much difficult to build, very tedious. And when you try to push inside the sheet, you make the irritator. So we found another geometry, very simple. It seems like a coil, and easy to put inside a container. So it's a technological advancement. Each adapter is just a tube, stainless steel tube. If it is break, just throw away. We have a counter electrode to give us a lot of information. The fact that it is a stainless steel tube helps because it reflects the temperature in the inner. So we have to give less power to reach temporary temperature, about from 500, we can be something. Maybe it is effective even at 300, but so weak that we are not able to measure with our system. This is sketch the system, glass tube, thick, three rockets, ecco, V1, V2, V3, V1 just because 100 micron is cracking, V2 200 micron, V3 300 micron. So very easy to remember. Here is a detail of the construction, but I will give you all my presentation. To describe this one maybe half hour, so too much. Anyway, you can have an idea how it's arranged. So it's not a real not a cappuccino, but a variation. The red one is the thermocouple. We measure the temperature at the core of the reactor. This gives a giant information. Allow us to make a big progress just because this thermocouple inside. Another view of the system, and other details about the gas construction. This is the reactor just after assembly. So we use the previous setup, the previous tube, everything previous, so we can compare data. Previous experiment. Here is put in the new flow calorimeter is a double wall high flow calorimeter with 4 screening sections, so the accuracy was improved in respect to last year's experiment. Another view of the system. Main result, the work is in progress. The most important effect I found about 2 weeks before. So the data that I will show you are raw data, just from computer, without elaboration. Point is the following. We have seen that adding some electric field to the anode or counter electrode had some effect on the chassis, little but significant. So we decided to study deeply if it was a fake or a real effect. Because 2 weeks before, no, sorry, okay, 2 weeks, 10 days before, were a big problems in our laboratory. We had to shut down everything because the main power broken, but not our laboratory. We have 2 days, no operation. When I come back to the laboratory, I decide to check if what we've seen sometimes was correct or not. And then, this is really our big surprise. The wire, the micro wire, was loaded temperature 0.84, stable. It was at the room temperature. So we decided to add step by step a positive voltage. The wire is negative polarized, but with the low power, few millivolts only. When we add voltage, the loading increases. This maximum voltage will wait and still increasing the loading. So we worry something wrong, some short, something like that. We take off power and come back to the origin. So we decide to reverse polarity from positive to negative we have the reverse effect. Small, measurable deloading. After we wait some 130 voltage and go down, check again for stabilization, all is correct, no mistake. At this point we want to check if it is possible using a C current from the main, either we have 150 volts main, can have some effect. I do simple geometry, and I give to the system. And it is able to react, not always, but to react. Positive, increasing, negative, decreasing. It can react, even at 50 Hz. So it means the hydrogen or something there, proton, something, are moving. It is not impossible. Even 50 Hz are moving. So again we check. Here we make unipolar pulsing, positive, and here negative unipolar. Some side effect we don't know, but not so important here. Again going zero. Now is the, okay. The main problem, at least in our experiment, that when we start the experiment at high power, high temperature, we have wonderful data. But later, this temperature inside the reactor going down. Increase again the power. Now, we use 102 watt, 150 watt. Again, high temperature, but later go down again. And we were, this is a typical experiment, we were not able to avoid this we call self-quenching. It tends to go to a minimum. If we wait 3-4 days, the value just going close to zero. So we need to change something. We need non-equilibrium. In this experiment, so we decided to use the 300 volts field, not room temperature, but at this point it was about 600 if I will see. So what we have found, instead of decreasing, it is increasing. So we found the solution. But if you wait longer time, this one again coming. So we just make some longer, better performance, but at a very long time, as it needed for practical application, again go down. So we think, okay, you need non-equilibrium. We use the positive voltage, it increases, okay. We stop, we put 0 voltage, the DC will stop. We decided to make a negative. When we make a negative, the temperature have a big jump, but a wide break. So it was too much strong reaction. It was completely unexpected. I suppose to reduce the power, but it is more. Decreasing of energy. This pushing of electron up, down, or protons, so hydrogen from this space is moved. So every possibility is open. This is the theory of my friend. According to him, there is this very complicated models. He has done his theory. And according to him, even based on our recent data, this model can work enough simply, and this is the paper where he explained everything. He is not a theorist, so I just give him opportunity to show. And I finish. Self-leaking of the system. So I give 100 watt with the wire, and I have extra energy.
But if you use more modern insulation, then
yes, but it's possible. Example, the geometry of super Capuchin reduced the input power to get such temperature factor 3. But remember, we need non-equilibrium. We need, if you insulate too much, you don't have non-equilibrium, so you kill the reaction. You have to have a dynamic condition. Example is very strange when you use it instead of iron tube copper, less performance about the temperature, but better about heat. So you need dynamics. Remember, cold fusion is dynamic system. It's a dynamic phenomenon. It's not static. When it's static, it will die flat. You don't like it.